So welcome everyone. So let's solve this problem. So why we choose this problem? Actually, this problem came this year 2024 JEE Advanced Paper 1. So what this problem state is following. So a source of sound has frequency 240 Hz that's reflect in this image, and when the observer O and the source S actually moves towards each other, like in case 1 at a speed of v with respect to the ground as shown in the figure 1. The observer measures the frequency of sound is 288 Hz. Okay, so this is the information provided for the case 1. Okay, so now however, when the observer and the source move away from each other, like in case of case 2 with the same speed v, then as which is shown in the case 2, so then what is the value of frequency, that observer observe? So that's the given in hertz, so we have to find the value of n. Okay, so now as we read the question, we understood that question is basically coming from the sound wave and the phenomena that's happened in these both the cases, which is called the Doppler effect, right? So so what is the Doppler effect? So Doppler effect states that when we have this sound wave propagate, and if the observer and the source actually moving from the initial position, then what happened, the frequency, the observed frequency is basically changes. It's not the actual frequency that sound wave emits at the source. Okay, so what is the Doppler effect? So Doppler effect is basically state as FO, that is basically the frequency experienced by the observer, is equal to Fs. Fs is basically the frequency emitted by the source at the initial position. That is basically multiplied by V and plus or minus of VO divided by V plus or minus of Vs. Okay, so FO and Fs is frequency experienced by the observer and frequency emitted by the source at the initial point, and V is basically the speed of the wave. VO is basically the velocity of the observer, and Vs is basically the velocity of the source. Correct. So now let's take to the first case. So first case is basically the, let's say, case 1. So case 1 is following. So F O is equal to Fs time V plus VO and V minus of Vs, is because if you see, the wave is actually moving from this source to this direction towards the observer, and observer is basically coming from, so exactly opposite to the speed of the wave. So that's why the relative velocity V plus VO. On the other hand, the source is actually moving in the same direction with the speed of wave. So that's why the relative velocity is basically the V minus Vs. Okay, so this is the basically the case 1. Okay, and that for the case 2, so for the case 2, so case 2 is basically the FO is equal to Fs times V minus of V naught times V plus of Vs. So this is because, like, if you see that in case 2, the source is actually moving opposite to the observer, so that's why the relative velocity is basically the V plus Vs. On the other hand, for the observer is actually moving in the same direction, like how like wave propagate from source to the observer, so it's the same direction. So that's why the velocity of the observer is negative of V naught, VO. Okay, so this is basically the two case. Okay, from the case 1 and case 2, this is to a relation. So let's put like F naught 1 and F naught 2, right? And in both the case, the Fs would be the same, right? So now what we know, that for the case 1, that F naught 1 is basically the 288 is equal to the Fs is basically the 240. So 240 times. So let's call this element let's say lambda. for our simplification of the problem. So then this could be, let's say, lambda, and this is the, let's say, relation 1. And for the case 2, we actually don't know the FO2, so that we have to find out for the value of n, and Fs would be the same, so that's why this, let's say, put n is equal to 240 divided by, and if you look at this value, so this is actually the inverse of this, so then this would be like 1 over lambda, right? So then this would be like 1 over lambda. So now we have to solve this two equation and find out the value of n, right? Okay, so just to multiply this, I mean, this is actually very easy to solve. So if you just multiply these two equation, so what we get is basically 288 times n is equal to 240 square, right? Good. So lambda is actually cancelling. So now to find the value of n, so that is basically 240 times 240 divided by 288. So if you just break this, so it's basically what we see, 12 times 20 and into 12 times 20, and from this side, if you taking out from the 2, then it's 144, and that would be like 12 cross 12, right? Okay, very good. So 12 cancel with 12, and 20 times 20 divided by 2, so it's basically the 200. So the n would be like 200 hertz. So n is basically like 200 hertz. Okay, so that's it. So that's the problem. We have to find the value of n. So now, as usual, we basically try to learn what we can expect from this question, or what are the additional things we can learn from this this phenomena called Doppler effect, and this by solving this problem. Okay. So in general, the speed of sound is actually given, right. So speed of sound, the speed of sound actually is given by square root of ks divided by rho. So the k is basically the coefficient of stiffness, so coefficient of stiffness, and rho is basically the density of the medium for any gaseous medium, right? So now what we know is basically the ks is equal to gamma times p. So gamma is basically the adiabatic index. So adiabatic index. So adiabatic index that we basically define as like Cp over Cv, right? In thermodynamics, what we learned is basically that quantity is actually determined through 1 over 2 by f. So where f is basically not the earlier frequency. So f is basically like degrees of freedom, right? So now to further simplify this relation, so that is basically written in terms of like square root of, just plugging this value of ks gamma times p and use for the ideal case that pv is equal to nRT. So r is basically the molar gas constant, and for the further simplification, that would be like gamma times kb times t and divided by m, small m. So k is basically the Boltzmann constant. So for a given system, this kb is constant. Kb is constant, and gamma is also constant, that coming from this relation, and the only depends on the system is basically the temperature of the medium, that and the mass of the single molecule. So the c the speed of light is proportional to t to the power half, and it's also proportional to m to the power like minus half. So as we increase the mass of the single molecule, the speed of light is decreases, and also if you like increase the temperature, so it would be like increase in square root form, correct? Okay, so now so that's the information we can collect from the properties of speed of sound. And if you look at for a particular given temperature, we can easily compute the velocity or speed of the sound wave. And in some cases the problem will be state something differently. Then you have to be careful and using this relation and evaluate the observed frequency for the given situation. Correct. Okay, so for the information, at 0 degree centigrade, uh, the speed of sound wave in air is approximately 331 meter per second. So that's in the SI unit. So that's the very standard value for here. Okay, that's it, and thank you very much.